Grade 11s, welcome to another series of iCamp lessons. We'll be continuing with our practice problems as part and parcel of covering trigonometry. If you have not watched the previous videos, please do start with watching the previous videos. They are very important because they lay the foundation of trigonometry and all the concepts. So it's usually easier if you understand why we are doing what we are doing, so that when we apply, we just focus on application, but we have covered understanding. So today we'll be covering a provincial examination paper. It's a November 2023 paper from Gauteng. You can even search it up. So today we'll be covering that paper, and it's strictly trigonometry. So let's see what we have today, right? So we are given question, it's question 5 in the paper. So we are being told that if sine, right? So we are being told that if sine, if 3 sine beta is equals to 2 and cos beta is is less than 0 or negative, determine with the aid of a diagram and without the use of a calculator the value of 3 cos squared beta minus 1 and the value of tan into negative beta minus 180 degrees, right? So the most important thing here, or when trying to solve this, right, when they say determine with the aid of a diagram, it means that the diagram will be very important in us answering this question, right? And it's also important that we don't use a calculator in solving this, right? So let's get into it. The first thing that I'm going to do is, remember I have 3 sine beta equals to 2. So what I'm going to do, I'm going to divide by 3 both sides, right? And then 3 and 3 will cancel, and then I'll be left with sine beta is equals to 2 over 3, right? So what do I know about sine, right? So what do I know about sine? So I know that sine of anything, which is sine of beta, is the same thing as opposite over hypotenuse, which is the same thing as y over r, right? Which is the same thing as y over r. So it means that my y is going to be, so it means that my y can literally be equals to what? 2, and then my r is going to be 3, right? But in terms of the sine, we'll get into that, right? So we have already established that, right? So another fact that we are being told, so another thing that we are being told is that your cos of beta is less than 0, right? Which essentially means that it's negative. Essentially means that it's negative. So in this case, already we know that your sine of beta equals to 2 over 3. This is indeed positive, right? This is indeed positive. So I am going to, for the purposes of a diagram, right? So for the purposes of the diagram, right, I'm going to use a cast diagram, right? I'm going to use a cast diagram. So in the cast diagram, what I'm going to be looking for, I'm going to be looking for a quadrant, where your sine, right? I'm going to be looking for a quadrant where your sine is greater than 0 and your cos is less than 0, right? It's negative. So that's what I'm gonna be looking for, right? So I'm gonna take you through a recap, right? A recap of a cast diagram. So let's just draw the cast diagram again so that we understand it. Right, so here you are going to have 0 and 360 degrees. So here you have your 90 degrees. So here you have your 180. This is going to be your 180 degrees, and this is going to be your 270 degrees. Right, so when we are talking about a cast diagram, you know that here it's going to be cos. So here it's all, here it's sine, and then here it's tangent, right? It's tangent. So everything here is positive, right? So this means that everything here is positive. So your sine, cos, and tan, they are all positive here, right? So they are all positive, but in here you only have your sine, which is positive. You have your cos, which is negative, and then you have your tan, which is also negative. And then here you have your tan as being positive. You have you have your tan as positive, you have your cos as negative, and then you have your sine as also negative. And then here you only have cos as positive, and then you have sine as negative, and then you also have tan as negative, right? So what we are looking for, so this one we can just even put a bracket here and say for when it's positive, right? And then here it just means that it's negative. So what we are looking for a quadrant where you have your sine as positive and your cos as negative. And if you look at this diagram, this is where we are looking for. So you have sine as positive, right? So let's just use a highlighter. So you are going to have your sine as positive and cos as positive, right? So that means that I am going to exist in quadrant 2. So we're supposed to name this. So this is quadrant 1. This is quadrant 1. This is quadrant 2. This is quadrant 3. And then this is quadrant 4, right? So that means that I'm going to be existing where I'm going to be at this position, right? So this is going to be my point. So I'm just going to draw the triangle here. So the triangle will be, okay, I don't know why it's not doing straight lines, but it's okay. So that means I'm gonna be here, right? And then I have my right angle here. Great. So already what do I know? I know that my y is what is 2 and it's positive, and then my r is what is 3. So now I want x, right? So I want x. So in order for me to find x, I'm going to use the Pythagoras theorem, right? So Pythagoras theorem, it's going to be r squared is equals to x squared plus y squared. Right, so what is r squared? R squared, it's already given, which is 3 squared is equals to x is what we are looking for, plus 2 squared. So this can also be written as x squared is equals to 3 squared minus 2 squared. So x squared is equals to 9 minus 4. and then x squared is going to be 5, and then we can take square roots. So x is going to be plus minus 5 root 5, right? But I'm going to choose the answer that is negative, right? So I'm just gonna say x is equals to negative root 5. Why? The reason it's because we are in quadrant 2. So that's the reason why we are choosing that. So the reason why we choose x is equals to negative 5, it's because we are in quadrant 2. And how is x in quadrant 2? X is negative in quadrant 2. So now we have what we need, right? So now we have what we need. So we can simply come here, right? So we can now simply come here and you can just take this and put it there, right? Great. So now we know that x now is equals to negative root 5. We know that y is equals to 2, and we know that r is equals to 3, right? So now we can go ahead and solve the question, right? So what does the question say? So we need to solve 3 cos squared beta minus 1. 3 cos squared beta minus 1. So the way in which we are going to solve that, right? Remember what is cos. So your cos is adjacent over hypotenuse, right? Cos theta is adjacent over hypotenuse. So that's how you are going to work that out, right? So now what I'm going to do is equals to 3, right, into cos squared. This is the same thing as adjacent, so it's x over r squared minus 1, right? And then this is going to be 3 into what is x? X is minus root 5 over what is r? R is 3 all squared minus 1, right? And then now I can simplify. I have 3, right? And then this will be the same thing as the square root will cancel, so it's going to be 5 over 3 squared is going to be 9 minus 1. And then now 3 goes once here and 3 goes 3 times here, and then I'll be left with 5 over 3 minus 1. And this is the same thing as 5 over 3 minus 3 over 3, which is equals to 2 over 3, right? So this is my answer. Right. Now let's look at the second question. So the second question, which is 5.1.2, it's saying turn into negative theta minus 180. So 5.1.2, so it's going to be turn into minus beta minus 180. Great. So what I'm going to do here, I'm going to take out the negative sign, right? I'm going to take out the negative sign, so it's going to be negative tan, right? And rearrange it. So now it's going to be 180 minus beta, right? It's going to be 180 minus beta, right? And then now I go back into my cast diagram, right? I go back into my cast diagram. Remember, we may have not put that. So 180 minus, it's going to be here, right? 180 minus, it's going to be in quadrant 2. It's going to be here in quadrant 2, because when we count on the angles here, we count going like this, right? we count going like this. So this is going to be 90 plus, this is going to be 90 minus, this is going to be 180 minus, and 180 plus. So tan 180 minus, right? Tan 180 minus is in quadrant 2. And how is tan in quadrant 2? It's negative. So this is going to be the same thing as your negative into negative tan beta, right? And then negative and negative will cancel. So you have tan beta. And then now it becomes easy. What is tan? Tan is your opposite over adjacent, which is y over x, right? And then we can substitute. What is y? Y is 2. And then what is x? X is negative root 5. Negative root 5. And therefore my answer is going to be 2 over negative root 5. I don't have to rationalize the denominator here. I can just leave it here, right? I can just leave it here. So this is how we solve this, right? So this is how we solve this. So if in a case where you may have forgotten, let's just try to write this here so that it becomes clear for when you go through this on your own time. Right, so here I'm going to have 180 minus, right, and 90 degrees plus, right? This can be theta, right? And then here it's going to be 180 degrees plus theta, and then 270 degrees minus theta. And then here I'm going to have 270 degrees plus beta, and then 360 degrees. 360 degrees minus beta. And then here I will just have my 0 degrees plus, it's just 0 degrees, and then it's also going to be 90 minus, should be 90 degrees minus theta, right? This is assuming that all the angles are just beta. So, because we were dealing with beta, let's just write beta here. But it can be anything. Beta, 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 beta. Great. I hope that is clear. Great. So now let's look at 5.2. Okay. So in 5.2 says given that t cos 15 degrees is equals to 4, determine the following in terms of t without the use of a calculator, right? So it's almost a similar question. So what we are going to do here, we are given that t cos of 15 degrees is equals to 4. Right, so I'm going to divide by t, yes, I'm going to divide by t, right, and then t and t will cancel, right, and then I'll be left with cos 15 degrees is equals to 4 over t, right? So what do I know? So what do I know about cos, right? What do I know about cos? I know that cos of any angle is equals to adjacent over hypotenuse, which is the same thing as x over r, right? So therefore it means that this will be, it's not 5, it's supposed to be t, right? That's what I know. This is what I know. Right, so now it means that my x can be 4, and then my r is going to be t, right? That means that I need y, right? That means that I need y, right? So I can simply just draw a triangle. So I can simply just draw a triangle. A right angle triangle, and then this is going to be my 15 degrees. I already know that x is 4. I already know that t is r. Then I want a y, right? So I can find y using a Pythagoras. So it's going to be r squared is equals to x squared plus y squared. So what is r? R is t squared, so I'll just have t squared is equals to 4 squared minus y squared, plus y squared. So y squared is going to be your t squared minus 4 squared. So what is 4 squared? So this is going to be y squared is equals to t squared minus 16, right? And then from there I can just do this. Right, so it's going to be y is equals to your root of t squared minus 16. Right, so now I have my y. Right, so now I have my y. This is my y. Right, it means that now I can go and solve the questions. Right, so 5.2.1, let's start with 5.2.1. Right, so they want cos of 15 degrees, right? Sine of 15 degrees. So sine of 15 degrees, right? So this is just going to be, what is sine of 15 degrees? So this will be your opposite over hypotenuse, which is just y over r, right? And then your y is going to be t squared minus 16 over what is r. R is just t, right? So I'll just stop here. I don't have to do anything else. I'm just gonna stop here. Now I have my answer. It's very simple, right? It's very simple. So in this case, we don't have to worry much about the signs because we're not given any conditions for which these can be true, right? In this case, we were given the conditions for which these equations were true. So that's why we had to apply the things that we applied. So now let's look at 5.2.2. So 5.2.2. So we have sine 75 degrees, right? We have sine of 75 degrees, right? Is it sine? Yeah. So if you have sine of 75 degrees, right? Your sine of 75 degrees, if you look into this triangle, you can find sine of 75 degrees, right? You can find sine of 75 degrees. Let's do this. Copy. So if you look into this, right, you can find sine of 75 degrees because you already know that your y is just t squared minus 16. It's going to be t squared minus 16. So if you do angles of a triangle, right, this is going to be just 75 degrees. And then you use that to find your answer, right? But the easiest way in which we can do this, right, we can come back to this. But the easiest way in which we can do this is by saying, right, we can also write sine as your sine of 90 minus 15 degrees, right? So if we know that sine 90 minus, it's a cofunction, right? So this will make this become your cos of 15, right? Why? Because this is a cofunction, right? And then from there, I can just go to my triangle. I know that what is cos of 15 degrees. Cos of 15 degrees is just me saying your x over r, right? Which is now going to be 4 over t. Right? Which is going to be 4 over t. Right? You could look at it in another way. But yeah, in this case, it's really not necessary. That's really not necessary. But if you were to look at it using another way, alternatively, so let's just say alternatively, if you like, alternatively, right? Alternatively, if you like, your sine of 75, if you are looking at that triangle there, your sine of 75, so you are saying sine of 75 degrees, right? So your sine of 75 degrees in this case will be your opposite over, hypotenuse, which is just y over r, right? So that means that this now, if this is the angle, right? If this is the angle, so this side is going to be now become, oh no, it's fine, we can deal with this. So this side now is going to become your opposite side, right? It's going to become your opposite side, or your y, right? If that is the angle in focus, right? So now that means that you can simply say your answer is going to be 4, right, all over t, right? So it still gives you the same answer. So in both methods, you should be able to win, right? In both methods, you should be able to win. Great. So now let's look at what we have for 5.3. So yeah, we may have to do 5.2.3, not 5.3. So yeah, we can let's just reduce this, make it smaller, and we will just put it here. Okay. Yeah, it's fine when it's here. So now we are going to look at 5.2.3. What is 5.2.3 saying? 1 minus tan squared 15. 1 minus tan squared 15 degrees, right? 1 minus tan squared 15 degrees. So we still going to rely on our triangle. We are still going to rely on our triangle to assist us. So we can just put it here, and this is going to be the root of tan squared minus 16, right? So in order for us to do that, we are just going to say 1 minus, we need tan of 15, so this is going to be your opposite over opposite over adjacent, so it's y over x all squared, right? We are still focusing on this, right? And then now this means that your 1 is going to be 1 minus, what is y? Y is that t squared minus 16 all over x, which is 4 all squared, and then 1 minus the square root will cancel, and then we have t squared minus 16 all over 16, right? Because 4 squared is 16. Remember, we need to solve this without the use of a calculator, so we can write 1 as 16 over 16 minus t squared over 16 over 16, right? And then this, let's just create some space in here. It's not necessary that we go to another page. Great. So if we write it like that, and then now we can have it's going to be your 16 will cancel with, yeah, this is going to be, this should be plus, right? This is going to be plus. So if we just do this, it's going to be your 16, right? It's going to be your 16. It's going to be your 16, right? And then this is going to be your 16 negative, and the negative is going to be positive, so it's going to be 32, right, minus t squared, right? So this is how you go about solving the last question. Quite fairly simple, right? It's quite simple. Let's look into question 3. Right, let's look into 5.3. Let's look into 5.3. So in this case, right, we are being told that we need to simplify the following to a single trigonometric function. Right, we need to simplify the following to a single trigonometric function. Right, so here we are going to rely more on cast diagram and reduction formula. Right, so I'm just going to write this again. It's not necessary that in every question you repeat it, but I'm just going to write it for visibility purposes. So it's going to be 90 degrees minus alpha times sine negative alpha minus 540 degrees all over your tan of 225 degrees plus your sine alpha times sine of 180 plus alpha. Right, so let's go ahead and do this. So your cos 90 negative, your cos 90 minus alpha. So cos 90, it's a cofunction and it changes into becoming a sine. Excuse me. It changes and it becomes a sine, so it means that you are going to have your sine alpha. Right. And then this one, what I'm going to do, I'm going to remove I'm going to remove the sign, right? I'm going to remove negative. So I'm going to have negative. So I'll just put a bracket. I'm going to have sine into 540 degrees minus alpha. Nope, it should be positive. Yeah, it should be positive alpha. And then close brackets over. So your tan 225, I can write tan 225 as, so usually you can use your calculator to see how you can write 225, right? So you can write tan 225 as, let's see if we do this. Okay, this one does not work, so let's see, 70 minus 225, it's 45. So I can write tan 25 as your tan, right, of 270 degrees minus 45 degrees, right, plus your sine of alpha times, right, we can also simplify this. So your sine of 180 plus 180 plus is in quadrant 3, so that means that this is going to be your minus sine alpha, right? Great. So now I can go ahead and try to simplify this, right? I can go ahead and try to simplify this. What I am going to do now is I am going to have your sine alpha, right? So this is the same thing as having a 360 plus, right? It's actually having a 360 plus or 360 minus. So sine angle plus, it's going to be negative. So it's going to be negative and it will make this positive. So I will still have your sine alpha, positive sine alpha. And then this can be your tan 270 minus is in quadrant 3. And how is tan in quadrant 3? It's positive. So this is going to be tan 45, right? Minus this is going to be your sine squared alpha, right? Because it's going to be sine squared times sine squared. Sine times sine is going to be sine squared alpha. Great. Now let's simplify and see. So I'm going to have my sine squared alpha over my tan of 45 degrees minus sine squared alpha, right? But remember, how can I write tan 45? Right? There's a way in which I can write tan 45, and tan 45 is an equivalent of 1, right? So tan 45 is the same thing as 1. So I'm going to have sine squared alpha equals to 1 minus sine squared alpha, right? Why? Because your tan of 45 degrees is equals to 1. Right, so now remember, what do I know? I know that cos squared alpha plus sine squared alpha is equals to 1. And in this case, I have 1 minus sine squared alpha, which is going to be equals to your cos squared alpha. Right, therefore, I'm going to have my sine squared alpha all over cos squared alpha. And this is just sine over, remember, what do we know, right? Your sine theta over your cos theta is the same thing as your tan theta, right? So therefore this is going to be your tan squared alpha, right? And then you have your 5 full marks. Right? So yeah, I hope you don't have any questions until this far. I hope you don't have any questions until this far. So now let's look at 5.4. It actually brings us to almost an end of our question, right? Which is question 5. So the question says that given 1 minus cos theta is equals to 2 sine squared theta, show that the equation can be written as 2 cos theta plus 1 into cos theta minus 1 equals to 0, right? So this is very simple. It's the same thing as a difference of 2 squares. So you have your 5.4.1, right? Remember, we are given that 1 minus cos theta is equals to 2 sine squared theta, right? So what I'm going to do, I'm going to transform, right? I'm going to transform this, right? I'm going to transform this. Remember, your sine squared theta plus your cos squared theta is equals to 1. So in this case, I have sine squared, right? So I need to change sine squared and make it be 1 minus your cos squared theta. So that's what I'm going to do. And then I substitute that back into that. So now I'm going to have 1 minus, right? So I can just say can even call this your equation 1. You can even call this equation 2, and this is your equation 1, right? And then you can simply say sub equation 2 into equation 1, right? So now you are going to have 1 minus cos theta minus, equals to 2 into 1 minus cos squared theta, right? And then from here, you are just going to have 1 minus cos theta is equals to 2 minus 2 cos squared theta, right? And then you can simply transpose everything, or it's better if we transpose to the left. So you are going to have 2 cos squared theta, right, minus cos theta, right? And then you are going to have plus 1 minus 2 equals to 0, right? And then this can also be written as 2 cos squared theta minus cos theta. And then 1 minus 2, it's minus 1 equals to 0, right? So from here, when you get to this, it's only 2 marks. You can just make a difference of 2 squares. So it means that it's going to be now 2. You're going to have 2 cos theta plus 1 into cos theta minus 1 equals to 0, right? And then now, that's where you finish. That's where you finish. So let's look at 5.4.2. What does 5.24.2 say? So 5.4.2 says, hence determine the general solution of the equation that we already found, right? So in order for us to do that, right, we already know that 2 cos theta plus 1 and cos theta minus 1 is equals to 0. So I'm going to say 2 cos theta plus 1 is equals to 0, or cos theta minus 1 equals to 0. So I will have 2 cos theta is equals to negative 1 divided by 2 divided by 2. This and that will cancel, and then I will have my cos of theta equals to minus 1 over 2, right? Yeah, I will have my cos of theta equals to minus 1 over 2, right? Was this supposed to be? Yeah, that's correct. And then the other side, it's going to be just cos of theta is equals to 1, right? Cos of theta is equals to 1. But we are not done here. We want the general solution, right? So we want the general solution. So what I'm going to do, I need a reference angle, right? So from here, I just need a reference angle. I need a reference angle, and if you do your cos into, your cos of inverse of negative 1 over 2, you are just going to get your 60 degrees, right? And then here, and then for here, your reference angle is going to be 0 degrees. If you do cos of that, you are just going to get 0 degrees, right? And then we can go to the other page and try to write our general solution, right? So where are we going to find this, right? It's cos where it's negative, should be negative, right? So your general solution will lie in quadrant 2 and quadrant 3 for this one. It's going to be quadrant 2 and quadrant 3, right? So in order for us to do that, it's going to be quadrant 2 and quadrant 3. So the first general solution is going to be your theta is equals to 120 degrees plus k times 360, which is the period, right? And k is an element of integers. And then the other one is going to be your 240 degrees, right, plus k times 360 degrees, and your k is also an element of integers. And the last one, which is the one that includes 0, it's going to be theta is equals to 0 degrees plus k times 360 degrees, and k is an element of integers, right? Right, so that brings us to the end of our questions. I hope everything was clear. Thank you for tuning in until this. If you will be seeing this on YouTube, please make sure that you like, comment, subscribe, and share the video. Thank you. See you on the next video.